Hello guys, we are Group 7 from Matematika Education class at Yogyakarta State University. We are here to present the result of our project regarding the English presentation of similarity and congruence in geometry. Before we start the presentation, please allow us to introduce our team first. My name is Salma Safira.
I am Nahiza Asti
Hello mate, my name is Hidayat Nur.
Hi, my name is Rahma Febriana.
Okay, in the first agenda is the definition and concept of similarity. The second is example questions about similarity, and then the definition and concept of congruency, and then example question about congruency, and the last is conclusion about the materials. Okay, let's go to the first material. There is the definition and concept of similarity.
Similar figures mean when two figures are of the same shape but are of different sizes. In other words, two figures are called similar when they both have a lot of the same properties but still may not be identical. For example, the sun and moon might appear the same size, but they are actually different in size. However, we are similar figures since both the figures are circular in nature. This phenomenon is considered as the property of similarity, keeping the shape and the distance in mind. So next to the definition of similarity. Similarity is when two or more objects or figures appear the same or equal due to their shape. This property is known as a similarity or similar figures. When we magnify or demagnify these figures, they always superimpose each other. In geometry, when two shapes such as triangles or polygons have the same dimension or common ratio but size or length is different, they are considered similar figures. For example, two circles are of the same shape but different sizes because they are similar. So next to the definition of similarity. Similarity is when two or more objects or figures appear the same or equal due to their shape. This property is known as a similarity or similar figures. When we magnify or demagnify these figures, they always superimpose each other. In geometry, when two shapes such as triangles or polygons have the same dimension or common ratio but size or length is different, they are considered similar figures. For example, two circles are of the same shape but different sizes because they are similar. Okay, next the symbol to express similar figures is like this. Shapes are also considered to be similar when the ratios of the corresponding sides are equivalent, that is while dividing its set of corresponding side length. The number derived is the scale factor. This number helps in increasing or decreasing the figures in size, but not in shape, leaving them looking like similar figures.
Hello, in the last part we have learned about the concept of similarity. Now we will try to solve the question about similarity. But before that, I want to review a little about the concept of similarity. Similarity in geometry is used to describe two shapes. The corresponding angles are equal and the side lengths are in proportion. Shapes that are congruent are also similar, but the shapes that are similar are not always congruent. Okay, let's go to the first question. Okay, first question. Given ABC similar with PQR, like on the picture, find the length of QR. Okay, because we have known that triangles ABC and triangles PQR are similar, we should not prove their similarity again. Okay, first step is we should know the side length that has the same proportion. Look at the picture clearly. From the picture, we know that triangles ABC and triangles PQR has the side length that have the same proportion. It is AB and PQ, BC and QR. Also, can you guess the last one? Yeah, very good. AC and QR. The next step is we can make the proportion equals. The way is the side length triangle ABC over the side length triangle PQR that have the same proportion. So it will be like AB over PQ equals to BC over QR equals to AC over PR. Because we are looking for QR and we have known AB, BC and PQ, so we're gonna use AB over PQ equals to BC over QR. We can substitute the number, so we got 3 over 6 equals to 4 over QR. QR is the side length that we are looking for, okay? We can do the cross multiplication, so we got 3 QR equals to 6 times 4. So we found that QR equals to 6 times 4 over 3, and we found that QR is 8 centimeter. Did you understand it? Did you all know we can use the concept of similarity in real life? Yeah, some examples of real life application are determining the height of an object. So we can predict the height of an object without climbing it, okay, or measuring it. The second one is scale models of buildings, scaling in construction, etc. And also analyzing of height of bridge stability. Okay, let's try to solve about this one. Okay, we go to the second question. A student is tasked with determining the height of a tree on the school. He aligns the tip of his shadow with the tip of the tree shadow. If the student is 5 feet tall, his shadow is 8 feet long and the tree shadow is 24 feet long. How tall is the tree? Okay, before we're trying to solve this question, we need to sketch it first, like on this slide. Yeah. The student aligns the tip of his shadow with the tip of tree shadow. From the sketch, we can conclude that the trees and its shadow make a triangle. Okay, we will call it trees triangle. And also the student and its shadow also make a triangle. We will call it student's triangle. If we can see, the student's triangle is inside the tree's triangle. So the student's triangle is similar with tree's triangle because it's inside the tree's triangle, and also when we resize the student's triangle, it can be congruent with tree's triangle. Okay, now we know that student triangle and tree's triangle are similar. So we can use the first step on the first question. The first step is we will looking for the side length that have the same proportion. Can you help me to find it? Okay, good. The first one is the height of student is have the same proportion, with the height of the tree. Okay. The second one is the shadow of student have the same proportion with the shadow of tree. Because we just know this information, we can use this information. So the next step is we make the proportion equal. So will be like the height of student over the height of the tree equals to the shadow of student over the shadow of the tree. Okay, we can substitute the shadow of student, the shadow of tree, and the height of student, and we know that, and we got 5 over x. X is for the height of the tree, right? We can estimate with variable equals to 8 over 24. We also can do the cross multiplication, and we got 8x equals to 24 times 5. Okay, we do the operation again, so we got x equals to 24 times 5 over 8, and we found x is 15 feet. So the height of the trees is 15 feet tall. Hope it helped you guys. Thank you so much.
Okay, we will continue to the next material. There is the definition and concept of congruency in geometry. At the first, we will discuss about the definition of congruency in geometry. In geometry, congruence refers to the size and shape of two geometric objects like lines, angles, shapes that are same or equivalent. Congruence is notated by the sign like in the PowerPoint. And the next material is the concept of congruency in geometry. We can analyze the concept of congruency from the following examples. 1. Two congruent line segments. In the image beside, we can see that the line segment PQ has the same length as line segment AB. So, we can say that line segment PQ is congruent with line segment AB, or PQ congruent with AB. And next, there are two congruent angles. In the image beside, we can see that the CAB angle has the same size as the RPQ angle, which is x degrees. So, we can say that the CAB angle is congruent with the RPQ angle, or CAB angle is congruent with RPQ angle. Material or example of concept about congruency in geometry is two congruent polygon shapes. Two congruent polygons are two polygons whose the angle can coincide and the corresponding areas of the polygons can overlap one another when passed. Some properties of two congruent polygons are that their corresponding sides are the same length. In addition, the pairs of corresponding angles are also equal. An example of two congruent polygons is in the image beside. Because the two polygons already have both conditions met, it can be said that the polygon RQPT is congruent with polygon CBAED.
Okay, because previously an explanation has been given about the material, so next we will discuss an example of congruence. Here is a question: if the length of the sides AB is 40 centimeters, BC is 21 centimeters, RS is 16 centimeters, and PS is 15 centimeters. A. Question: find the side lengths AD, DC, PQ, and QR. Then part B, if the size of angle A is 60 centimeters, angle B is 40 centimeters, the question is how big is the angle R and angle S. Because it is known that the trapezoid shapes ABCD and PQRS are congruent, we can write that the shapes ABCD are congruent with the shapes PQRS, meaning that the corresponding sides must be the same length and the corresponding angles are the same size. So if we look at the trapezoid ABCD and PQRS, to make it easier for the trapezoid PQRS, we change its position so that its position can correspond to trapezoid ABCD. So if the PQRS trapezoid is in accordance with the ABCD trapezoid, we can answer question A and B. In question A, what is being asked is the side lengths AD, DC, PQ, and QR. We start from the side length, and if we look at the position, the length of the side and corresponds to the position of PS. So we can write that AD is the same as PS, and PS in the question is 15 centimeters long, so we get that the length of side AD is equal to 15 centimeters. Next, for the length of the DC side, that the DC position corresponds to the SR or RS position, so we can write that DC equals SR. In the equation, SR has a length of 16 centimeters. This means that the side DC is equal to 16 centimeters. Next, for the side length PQ, we can see from the problem the position of PQ corresponds to the position of AB. So we write PQ equal to AB in the problem. AB has a length of 40 centimeters. This means that the side length of PQ is also 40 centimeters. Next, for the length of the QR side, QR corresponds to the position of BC. So we write that QR equals BC, and in the problem QR has a length of 21 centimeters. Then we get the length of the side of QR equal to 21 centimeters. Continue in part B. Here, what is asked is the size of the angle R and the size of angle S. The angle R and S are in the PQRS trapezoid. Meanwhile, what is known in the problem is angle A and angle B, where the position of the angle is on the ABCD trapezoid. So let's first look at the appropriate position. For angle A, it is known that the problem is 60 degrees. Angle A corresponds to angle B, so we can write that the size of angle P is equal to the size of angle A because it corresponds, and we get angle A of 60 degrees. That is, the measure of the angle P is also 60 degrees. Then angle Q corresponds to angle P, so we can write that the size of angle Q is equal to the size of angle P, and the angle P that is known in the problem is 40 degrees. So we get the size of angle Q, which means it is equal to 40 degrees. Since we have obtained the P angles of 60 degrees and the Q angles of 40 degrees, which means that we can find the S angle and R angle. For angle P and angle S, if the total is 180 degrees added up, the rule is taken from two parallel lines. Lines PQ and SR are two parallel lines cut by a line PIS. So we can write down the angle P plus the angle S equal to 180 degrees because we have obtained the P angle of 60 degrees. It means that we will find the size of the S angle. Then the S angle size is equal to 180 degrees minus the P angle, equal to 180 degrees minus 60 degrees is equal to 120 degrees. So the measure of angle S is 120 degrees. Then for angles R and angle Q, when added together, the result is definitely 180 degrees. So we can write that the measure of angle Q plus the measure of angle R equals 180 degrees. So we will find the size of the angle R, meaning that the size of the angle R is equal to 180 degrees minus the size of angle Q. Then we enter the value for the size of the angle Q. We have obtained 40 degrees, meaning 180 degrees minus 40 degrees. The result is equal to 140 degrees. So we get the angle R is equal to 140 degrees.
The materials of Congruency and Similarity in Geometry is finished, and if you want to ask our team, please write the question in comment column, and don't forget to like, share, and subscribe this channel. Goodbye, thank you, and see you next time.